So we're doing the 2013 question 1 FRQ. And it says, on a certain workday, the rate in tons per hour at which unprocessed gravel processing plant is modeled by G of t equals 90 plus 45 cosine of t squared over 18, where t is measured in hours and 0 is less than t and less than 8. At the beginning of the workday, t equals 0, and the plant has 500 tons of unprocessed gravel. During the hours of operation, 0 is less than t, and which is less than 8. The plant processes gravel at a constant rate of 100 tons per hour. And A is saying find G prime of 5. And it's also asking us to interpret your answer in the context of the problem. So to do this, we have to find the derivative of G of t, which is negative sine, negative 45 sine of t squared over 18. And then we do the chain rule, so then you do the derivative times the derivative of this, which is low d high minus high d low, which is low d high, so 18 times 2t over 18 squared, because the derivative of this is 0, so then 0 times this equals 0, so you're subtracting 0, so it doesn't really matter. Oh, this is squared. And then you can cancel this out, so you have 1/18 now. Now you have a 9. So then the final product is G prime of t equals negative 45 sine t squared over 18 times t over 9. You plug in 5 to this because we're finding G prime of 5, and you put it into your calculator and you get negative 24.588 tons per hour squared. And yeah, you can just plug it into your calculator and it's gonna work. And then it's also asking us to interpret the problem. So this number represents the amount of gravel, like it's the rate at which gravel is arriving, and it's decreasing because it's negative. So the amount of gravel arriving is decreasing by 24 tons per hour. For part B, we're trying to find the amount of unprocessed gravel that arrives at the plant from the hours of 0 to 8. And so we do that by finding the integral from 0 to 8 of G of t, which equals 825.581. And so you just plug in G of t into the equation. Like you can plug this into you're allowed a graphing calculator in this. So you just plug this into your graphing calculator, and we're doing the integral because we're trying to find we're not trying to find the the rate that, like, this would be like finding the rate of the gravel arriving, but we're trying to find the amount of gravel arriving from time 0 to 8. So we have to do the integral of G of t. To finish off the units for this is tons. For part C, it's asking us, is the amount of unprocessed gravel arriving at the plant increasing or decreasing at time 5? So first thing we have to do is find G of 5, which is, if you just plug it into your calculator from the original equation, 98.140. And so now how can we find out if it's increasing or decreasing? The amount of gravel being processed per hour is 100 tons. So if it's so we're comparing 100 with 98.140. And so obviously the 100's bigger. And if this is the amount of gravel, like this is the amount of unprocessed gravel arriving, and this is how much they process per hour. So this means that the amount of gravel arriving at time 5 is decreasing because less gravel keeps arriving. So not less than 100 is being processed. And so if this is the maximum it can process, then what's arriving is way less. So it keeps, over time, the amount of unprocessed gravel is decreasing. So for part D, it's asking us to find the maximum amount of unprocessed gravel at the gravel place from the whole workday. So we do that by doing, let's find out a new letter. Let's use A. So we're going to do A of T equals 500, because this is how much gravel we started out with. This is how much unprocessed gravel we started out with. So 500 plus the integral of 0 to t, because we don't know what time it is yet. Like, we don't know what time we're trying to find yet. And then we do g of t, right, minus 100. Because each hour, you're minusing 100 tons. You're subtracting 100 tons because that's how much is being processed. G of t. Okay? And then, now, we have to find the derivative of this to find the amount of gravel. So, the derivative of this is just g of t minus 100, because the integral, because the antiderivative of, because the derivative of an integral is just the function inside the integral. So that's okay. And then this equals 0. So this is what it is. And so now we have this. We have to find where this equals 0 to find the maximum. To find where it equals 0. So this equals 0 at 4.92. And so we have to test the points with the regular graph, with the regular function. 0, 4.92, and 8, because that's where that's where they all equal 0. And the most amount of processed gravel we have is 635 tons at this time. So at time 4.92, 635 tons were unprocessed, and that's the maximum amount of unprocessed tons we've had the whole day.